Alright, here we are looking at the homework on page 646, I believe. And first of all, we have to look at the drawing. We've got a situation here where we have a fork in the road that begins right here and ends right there. Therefore, objects B and C are parallel to one another because of the fork in the road, multiple paths. Object A is in series with them, and our goal is to find the equivalent resistance of those. So we need to do our parallel rule for B and C and then add it to A. So let's start doing a little bit of math here, and I have made a little spreadsheet to help me do it. So resistor B is 3 ohms, and resistor C is 40 ohms. Now, what I did was 1 over 3, 1 over 40. To do that, 1 over 3 plus 1 over 40 equals, let me hit enter here, equals 0.358. And then I have to do my reciprocal work because we have that rule of, and I'll bring that back up, 1 over R equals 1 over 3 plus 1 over 40. And that's not on the recorded screen. Let me scoot the recording over a second here. That's not what I wanted to do. I wanted to scoot the entire recording. Here we are. There you go. 1 over 3, 1 over 40. I guess it was on there. That's that. So when I bring this back up, then I had to take the reciprocal, so I had my 0.358 is the combination of these guys. Had to go reciprocal style on it, and that gave me 2.78. And then I have to add that, so equals plus, or equals this plus the other resistor right here, 25, enter. And it's 27.8 really should be what your answer is for letter A. Then if we reset our work and do letter B, we're going to put in, instead of 3, we're going to put 35 ohms. Instead of 40, we're going to put 25 ohms. And go into here. So that gave us 0.06, and then we have to take reciprocal, we get 14.58, and then we have to add that to letter A, which is 12 ohms, and we get 26.58 as the 26.6 would be good enough there. That'll be the equivalent resistance for part B. For part C, resistor A, let's change that straight away here. Resistor A is 15 ohms. Resistor B is 28 ohms. Resistor C is 12 ohms. Enter. So 1/28 plus 1/12 equals 0.1198. And then we do the reciprocal, and then we get 8.4 is our equivalent resistance, and we add the 15 to that. Add the 15 to it, and we should have an answer of 23.4. So that's number 1. Again, we did a parallel section, and then we're able to do a series section with adding A to it. So now we'll do basically the exact same work here, except now we also have to add in, when we look at this drawing, now we have A and B are in parallel, C is all alone, D and E are in parallel because, again, where do we have forks in the path? There's a fork here, there's a fork there. There's a fork here, there's a fork there. So everything between the forks is parallel. Everything between the forks is parallel. So we're going to do the exact same kind of idea. Pull up that spreadsheet again. And we're going to find, give me a moment just to kind of set up a spreadsheet. Alright, we got all set up. So now we're going to plug in our numbers into the old spreadsheet. And let's see, resistor A is 25. Resistor B is 3. So 1/25 plus 1/3 equals 0.373, and then we have to take the reciprocal of that, so it has equivalent resistance AB, section AB only, has the equivalent resistance of 2.67. 2.678, right there. Then we'll put in resistance D, which is 15, and resistance E, which is 18, and 1/15 plus 1/18 is 0.122, and then the reciprocal of that is 8.11. So right now we've got 2.67 plus 8.11 plus resistor C, which is all alone, and it's 40. And we hit enter. So our answer should be right around 50.1, or well, 51 or so. Yeah, that should be what our answer is for letter A. Letter B, we change our values. Resistor A in the second part is 12 ohms. Resistor B is 35 ohms. Enter. So 1/12 and 1/35 gives you 0.11. Take reciprocal, 8.99. Resistor D is 50. Resistor E is 45. Enter. So a 50th and a 45th is 0.04, equivalent resistance of 23.68. So we have our 8.99, our 23.68, and we add in resistor C, which is 25. Enter. We should have an answer of 57.6. Our main focus on this homework is equivalent resistance. Our next task will be go and find things like current and voltage for each portion of those. We will be spending time on that in our next class meetings.